Today, we're jumping into a really fascinating idea from a paper by Dr. Ken Solis. It suggests a whole new moral compass for our incredibly complicated world, one that isn't based on what's good for humans, but on information itself. Yeah, you heard that right. Let's get into it. So, let's just start with a huge question. Are our ethics outdated? Seriously, are the moral tools we've been using for centuries, the ones we got from ancient philosophers, are they even sharp enough for the problems we're facing today? Because, let's be real, the world is throwing challenges at us that our old ethical playbooks were never, ever designed to handle. We're way past just talking about how people should treat other people. The whole game has changed.
Which brings us to our first big idea here. We need an ethics that goes beyond beyond us.
I mean, just think about this stuff we're grappling with. Climate change, mass extinctions, the potential rights of a super-intelligent AI, planning for future pandemics. These problems affect entire ecosystems, things that aren't human at all, and generations of people who haven't even been born yet.
And this right here is the key. Almost all of our classic ethical systems, from Aristotle's ideas about virtue all the way to Mill's utilitarianism, they're all fundamentally anthropocentric. It's a big word, but it just means they're all about what's good for people. But what's good for the planet or for a future AI? Our old maps just don't have that territory on them.
So, to build a new map, this theory says we have to understand a conflict that's baked into the very laws of physics. It's a story with a universal villain and a universal hero. The mathematician Norbert Wiener called this the universe's arch-enemy, disorganization. It's that natural force that just breaks things down, creates chaos, and unravels any kind of order. And that, right there, is our villain. And this villain has a name you've probably heard before: entropy. In simple terms, it's the second law of thermodynamics just doing its thing. It's the reason your headphones get tangled in your pocket, your coffee gets cold, and why, over enough time, everything just tends to fall apart. Let's visualize this, because it makes it really clear. Think about a tidy room. There are only a few ways for it to be perfectly organized, right? That's a state of low entropy. Now, how many ways can that same room be messy? Millions, basically infinite. That's a state of high entropy. The universe is always pushing towards the messy room, towards more chaos. So as things fall apart, this theory says they are moving to a fundamentally worse state. Okay, so if entropy, disorder, is the villain of the universe, who's the hero? It's the force that fights back. It's the principle of order and structure itself: information. But, information is a kind of slippery word. It can mean a lot of different things. So to really understand our hero, we need to know that it actually has three distinct faces, or three different types. First up, we've got syntactical information. This is the most basic building block. And for this one, you can just forget about meaning for a second. This is purely about structure. It's about how things are physically ordered and arranged in space and time. A perfect example is a recipe. The list of ingredients is one thing, but it's the order of the instructions, the syntax, that determines whether you get a delicious cake or, a complete disaster. That structure is syntactical information. The second phase is semantic information. Now, this is information that actually means something to an agent. And that agent could be a person, an animal, or even a single cell. It has a purpose. And this is a brilliant example because it shows that meaning doesn't require some big, complex brain. When a little bacterium senses a chemical and moves toward it, that chemical signal has semantic information. The meaning is simple, but it's there. Hey, food's over here.
And the third and final type is called surprise information. This idea comes from the father of information theory himself, Claude Shannon. And really all it is any new information that reduces your uncertainty about a situation.
The classic example here is Paul Revere. Okay, so before he saw the signal, there were two possibilities, right? The British were coming by land or by sea. 50-50. But the moment he saw two lanterns, one of those possibilities vanished. His uncertainty was cut in half. He just gained one bit of surprise information. So, what happens when you start layering these different types of information, especially that deep structural kind? Well, you start to get some of the most valuable and amazing things in the entire universe: complex systems. So what exactly is a complex system? It's not just something that's complicated, it's got specific features. It's made of lots of different parts all interacting without a central boss, kind of like a flock of birds. It needs a constant flow of energy just to fight off entropy. It produces surprising, emergent behaviors you can never predict just by looking at its parts. And it organizes itself and adapts all on its own.
A complex system like a rainforest lives in this amazing creative sweet spot. It's not rigid and predictable like a crystal, and it's not totally random and chaotic like a cloud of smoke. It exists right there in the middle, on the edge of chaos, and it's dynamic, adaptive, and just brimming with that deep, structural, syntactical information.
Okay, so we've met the villain, entropy. We've met the hero, information, in its 3 different forms. And we've seen its greatest creation, the complex system. Now, let's put it all together and find our new moral rule.
Here it is. This is the core principle. The good is anything that protects or increases the net positive, informationally rich things in the universe. We're talking about things like living organisms, healthy ecosystems, or thriving, rich cultures.
So you see, the ultimate good isn't just one thing. It's a combination of all 3 types of information we've been talking about. You take the deep structure of a complex system, that's complexity. You add the novelty of surprise information, that's rarity. And you combine it with the purpose of semantic information, that's meaning. The more of these 3 things an entity has, the more complex, rare, and meaningful it is, the more good it represents in the universe.
And that leaves us with a fascinating and maybe a little uncomfortable final question. If this theory is our new compass, how does it change our map of what's valuable? If we measure good by the depth of organized complexity, does an ancient rainforest, with its millions of years of coevolution and informational richness, actually have more intrinsic moral value than a human city? It's a question that really challenges our place in the universe, and it's one that's definitely worth thinking about.